Good morning. Welcome to Rogni College of Engineering and Technology. Myself, I am Reggie, Associate Professor, Department of ECE. Today we are going to see the topic physical concept of radiation. Once we completed this topic, students can understand the physical concept of radiation, define radiation, nearer and far field region. Physical concept of radiation. In physics, radiation is the emission of transmission of energy in the form of waves or particle through space or the material media. This include electromagnetic radiation such as radio waves, microwaves, infrared, visible light, ultraviolet rays, X-rays and gamma rays. Electromagnetic radiation travel in the form of constant speed. The wave characteristics of EM radiation are found in the relationship of velocity to wavelength and expressed in terms of frequency and expressed by the formula C is equal to lambda V, where C is the velocity and lambda is the wavelength. Nearer and far field region. When a signal from the transmitter is applied to an antenna, it sends out electromagnetic waves into free space. The EM field characteristics may vary as the function of distance from the antenna. There are broadly classified into two regions, nearer field region and far field region. The nearer field region right next to the antenna, it is defined by the equation nearer field less than 2d square by lambda, where d is the maximum linear dimension of the antenna. Lambda is the wavelength of EM waves. In this region, the field are sort of unpredictable and there is no measurement. They are usually made in region. This region is classified into two parts. Reactive near field. This is the region adjacent to antenna. In this region, E field and H field are 90-degree out of phase with each other and therefore reactive. To radiate or propagate EH field need to be orthogonal or perpendicular. Reactive near field. Reactive near field is less than 0.62 the whole cube, which is d square by lambda, where d is the maximum linear dimension of an antenna. Lambda is the wavelength of EM waves. Radiative near field. This is also called Fresnel region. It is the region between reactive near field and far field. This is the region where the EM field start to transit from reactive to radioactive field. However, since they are not completely transited, the shape of the radiation pattern still varies with the distance. Radiative near field. 0.6d the whole square into d cube by lambda is less than radiative near field region less than 2d square by lambda, where d is the maximum linear dimension of the antenna. Lambda is the wavelength of EM waves. Far field region is the region that come after the nearer field. In this region, EM field are dominated by radiating field. The E and H field are orthogonal to each other and the direction of propagation as the plane wave. The far field region is represented by the equation. Far field is greater than 2d square by lambda, where d is the maximum linear dimension of the antenna. Lambda is the wavelength of EM waves. Antenna are usually used to transfer signal at a large distance, which is considered to be in the far field region. So most of the antenna which is used in far field region. One condition that must be met when making measurement in far field region, that is the distance from the antenna, must be greater than the size of the antenna and the wavelength. Diagrammatic representation. You see here there are two fields, nearer field and far field. Nearer field will have non-radioactive and radioactive. Non-radioactive is the reactive and radioactive will be Fresnel region which is connected to the antenna. So if you see the far field, how the antenna or the line of sight of propagation will be available compared to the reactive and non-reactive system. So most of the cases, the diagrammatic representation of antenna, how a antenna will transmit the signal in the terms of far field as well as the nearer field. So two quiz question. Dash is the region between nearer field region and far field region. Dash is the region that is adjacent to the antenna. So in both the cases we want to know how what is a nearer field region and far field region, and how it is applicable to an antenna or in an antenna system. Thank you.